All right, we are continuing working with rational exponents, which means exponents that have fractions. I'm able to convert it to radical form and vice versa. Now, when you're working with stuff, it's really kind of up to you how to work with these the best. So, what are going to be some things that are helpful for us? Like, for instance, if you're working just with variables, sometimes it's just easier to work with the exponential form. So, if you're working with variables, and I'll give you a silly little example of this, I would keep in exponential form. Actually, I think it's almost easier. Unless told otherwise, okay? This is kind of the form that you're going to get it. So here's what I mean, like on here. If I'm going to do, let's say, x squared raised to the 1/3 power, how would you simplify that? That's going to be x to the what? No, 2 times 1/3. 2 over what? I'm not making that harder. Are you guys with me on that? So it'd be x raised to the 2/3. Keep it that way. When you're working with numbers, it is always best. Let's see if I can move this thing that's in my recording stuff out of the way here. It is the best to convert to the radical form and then simplify. All right, so a quick little easy example of this that you guys probably all could do at this point, okay, would be something like 8 to the 2/3 power, okay? So when we're doing this, we said we're going to convert to the radical form. Well, how could I rewrite that so that's a radical? What would you have done? So we're going to sit there and go, that's going to be the 3rd root of what? And then we're going to do what to that? Square. Would you guys agree? So what is the cubic root of 8, which all of you know? So 2, but I have to do what to it? And we get the fact that's 4. That's kind of the processes that we're talking about. Try to do it the easiest way, this sounds mean, the easiest way possible if you can, all right, when you're working with it. But that's just using that idea. Now, a lot of this is you having to come up with the most common sense approach to do stuff. Now, notice that there was some reminders put here on the algebra teachers from the past. And this is just our exponent rules, right? Guys, if we have the same base, what do you do with your exponents? You add them. If you have a monomial, which means one term, have I emphasized that enough at all this year? A monomial to one term, what do you do with your exponents? You multiply them. Now, if I still have one term, but I have multiple variables, everything gets raised to that power, correct? We do that with numbers, variables, all of those. And if I have a negative exponent, don't they just mean flip the part of the fraction that you're in? And if I had something like here, a to the negative m, that would flip a to the m over what? 1. We know how to do that. Weren't we already moving negative stuff over the weekend and things? So that's not any different. Also, when we're working with exponents, and if we have fractions when we're working with it and they have the same base, aren't we just doing subtraction of the variables? I mean, of the exponents, not variables, of the exponents. And if I have a fraction, everything is raised to that power. Have the rules changed? No, they just look nastier because we have fractions. You have to be more confident with your fractions. All right, so let's do this one together and see if we're going to be able to make it so it makes a little more sense. All right. First things first, we have 8 times x to the 15th, all raised to the negative 1/3 power. Guys, do not be that person who messes up, okay? What should you do the moment you see that negative? Shouldn't you flip it, right? Shouldn't we realize this is over 1? So we're going to go 1 over 8x to the 15th, all to, now the positive 1/3 power. Okay. Now, here's where you can kind of decide how you want to do this. Now, when I look at this, I'm going to go, okay, I'm just going to do the power property. Wouldn't you guys do the same thing here? So that becomes 1 over 8 to the 1/3 power times x. Guys, that becomes what? 15 over 3, because what's 15 over 1 times 1/3? 15 over 3. Would you guys agree? Okay. So then what do we get here then? I have 8 to the 1/3 power. How would I rewrite that so that makes sense in our brain? I got the cubic root of 8 times, guys, what's x? Now notice I put a parenthesis there because do I need to do the radical sign with my variable? Because guys, what's 15 divided by 3? So that's just x to the what? 5th. So when I'm working with that, what's the cubic root of 8? So 1 over 2 times x to the 5th. Now I had a couple people, like when I've taught this or reviewed this with students before in the past, they're like, hey, can I go, if I know that 8 to the 1/3 is the cubic root of 8, could I go straight down to there? Yeah, but most people need to see that step. Most do, especially when it's numbers. Not as much with your variables, but that's kind of the way when you think about it. All right, does that example make sense? All right, let's look at the next one. Now we have 243 times a to the negative. This should be a 10 here. So sorry, I think it's 0. Did yours have a 0 on it? Some had a yes, some had a what? So yours actually had it? Huh, it must have just printed weird on mine. All right, all raised to the 2/5 power. All right, so with this, are we going to use the power property? Okay, so I'm going to use the power property on this. And I'm going to get 243 raised to the 2/5 times a raised to the what? Yeah, the negative 20 over 5. Ooh. Not a lot of fun, but it's okay to do. How would you rewrite the 243 raised to the 2/5? How can I rewrite that and somehow get something that's kind of nice? We're going to take the 5th root of what? And we're going to do what to it? Exactly, square it. Because I don't want the number to be big when I'm squaring it. Would you guys agree? Especially, now, if we had a calculator, would I care if you squared the 243 and then took the 5th root? No, but what if I don't give you a calculator? And then this one becomes a to the negative what? Negative 4. Now, so it means we're going to do some movement, right? Now, let's see if we can throw a little bit of steps here. Guys, what's the 5th root of 243? It's 3. It is 3. Yeah, it's 81 times 3, right? It is 3. That was the best guess because of what number right here? 3. It really was. So 243, just so you remember, this would be the same thing as like 3 times 81, and then that would be your 3 times 3 times 3. Are you with me on that? So that's where we got. So that becomes 3 squared. I'm going to leave the a to the negative 4 just till the end. What's 3 squared? 9. All right, now guys, can I have a negative exponent in my final answer? No, so that becomes 9 over a to the positive what? 4. Are you seeing how you're like, Pearson, you're changing everything to radicals right away with, yeah, I am, with my numbers, just because the numbers are nicer that way. Exponents, I might have to do a little bit more. But right now, let's go ahead and simplify as much as we can. All right, you ready to do some more? We're just going to be practicing these. Ooh, that one looks fun. That one looks great. Now, for some of you, I'm going to show more steps than what you need to. I admit that. But many of you need to show steps, period. So here would be something for those of you who are struggling a little bit. Would you agree with me? I can do the power property for this. So you might need to do this. When I have x here, you might have to go, that's 1/2 times a negative 6 over 1, just so you can see where the numbers are coming from. You'd also go y to the negative 2/3 times a negative 6 over 1. Like, if you have to show that step, am I going to stop you? And for some of you, you might not want the multiplication done. You might want to use parentheses instead if it gets too confusing for you. But when you do that, it gets really nice because that's x to the negative 6 over 2. This becomes y. What's a negative 2 times a negative 6? Positive or negative? Positive 12 over 3. Do you see where this is getting nicer then? So I get x to the negative 3, y to the, are we done? No. We just have to make sure we move our negative x's, right? So the x has to move to the denominator. So that's y to the 4th over. All right, I'm pausing for a second. How do you guys feel about this? You guys feel all right? Okay. Now, remember, do rules change just because we have nasty fractions? No. So guys, are we multiplying two things together that have the same base? They're both what? Y. So what do you do with your exponents? No. What do we do with our exponents? Add them. So you get y to the 1/2 plus 3/10. Oh no. They're fractions. In order, see why we reviewed fractions before we did this stuff. Guys, how do I add fractions? You have to have a common what? Alright, so that's going to give me 5. That has to be 5. Alright, so that now becomes our y raised to the 5/10 plus 3/10, which reduces down to 8/10. Can we simplify that? Yeah, that'd be y to the what? 4 over 5. Now, could I rewrite that to put it in radical format if I wanted to? Notice they said you can convert it and leave it in what form? Exponential form, as long as it's simplified. But if you really wanted to, could you go to like the 5th root of y to the 4th? Do those mean the same thing? Yeah, but if I'm working with variables, a lot of times it's like, why am I switching my fractional stuff if I don't need to? As long as your fraction's been simplified, are you pretty much in a good space? Yep. Yeah. So you're in a good spot. All right, you ready for the next one? You guys are like, this isn't bad. You guys whining. All right. What is this one?
No, add that one now. This one. Oh, put it to this one.
Oh, you'll get there. Okay. You'll get there. You'll be ready. All right, my friends, what would you do first? Every power property, right? And doesn't that power property have to go to every single thing inside that parenthesis? All right, so let's go there. Every single one of the parentheses. So we got here 25 to the what? 1/2. X2, and if you need to, I'm not afraid to go 10 times 1/2. We get y raised to the 1/2. Oops, not y, 9 raised to the 1/2. Make sure I write the right thing down. And then we get y equals 8 to the 1/2. Okay. Ooh, not the best feeling in the world, but I'm okay with it. All right, 25 to the 1/2. That's the same thing as doing what? Not dividing. Square root of 25. Now, on the next part here, that's going to be x. What's 10 times 1/2? That's x to the 5th. All right, 9 to the 1/2. Notice I'm just rewriting square root of 9. And then y to the 8 times 1/2. What does that give us? 4. Y to the 4th. Okay, I'm putting parentheses there because I don't want you to like try to do something else with those. Basically, if we simplified our exponents. Now we just got to do the math. What's the square root of 25? So it'll be 5x to the 5th on top. What's the square root of 9?
3.
Are we good? What do you guys think? Not what? Not too bad? It's not bad though.
There's too much work.
How fun
What
is
is
this
this?
one?
What is this?
This is so much fun.
What? No.
Now, all those years you've avoided fractions are going to come back to haunt you at this moment. Is really what's happening, friends. Come on. We totally can rock this. First of all, do I have to do anything to this a 5 to the 4th power right now? No. So let's leave it alone. So we got a to the 5/4. I'm going to get rid of the parentheses because that's what order of operation tells me to do. So what do we get there? That becomes 2 raised to what power? 3rd, right? And really then we get a to the 3/4 times what? Isn't that 3 over 1? And we're going to leave the a to the 1/4 here. All right, let's do some simplifying. We got a to the 5/4. I'm not going to do anything with that one yet. What's 2 cubed? A to the 3/4 times 3 over 1 is a to the what? 9 over 4. And I haven't done anything with the a to the 1/4 yet. All right, now should I start combining things? All right, what do we normally put first? Don't we normally put the 8 first, right? Guys, should we be able to combine these because they're being multiplied? All right, so that becomes, and really you're going to the 5/4 plus 9/4. Can you guys tell me what that would give us? 14/4. So can we go and just add it? Are you guys good with that? So I'm going to put 14/4 there because I don't want to have to write more than I have to. But if you're bad at fractions, show another step. All over a to the 1 what? Awesome. Can I do anything? Yeah, we still have to keep going now, right? Because I have the same base now in this fraction. What do I do with the top one at the bottom? Notice I didn't reduce it right away until I was done. Because now I can just subtract it. And so that really becomes a to the 14 over 4 minus 1/4, which gives you what? So 8 times a to the 13 what? 4. Takes a little bit of time. That's not too much work. Guys, I could be having you factoring like crazy right now. Oh, wait, let me start back to that again. Oh, this week. Oh, it's going to be a beautiful week. Beautiful week. Beautiful week. Beautiful week. Beautiful week.
No, when you said we were factoring against he smiled at me. He was like,
I taught him well.
No,
what can I
no,
say? I
no,
taught him
you
well.
brainwashed
All right.
this man.
All right. Let's just pray for him. He's having me a 3rd year in a row.
I feel bad.
I know. We need to pray for him. So far, I haven't completely messed up his math world. All right. All right, let's keep on going. Friends, order of operations. Got to get rid of what first? Parentheses, right? So let's do this one. Let's get rid of the parentheses. So this becomes 2 times a to the 4/3. And really, that's a to the negative what? Yep, 9 over 4. Do I need to show the in-between step there? Nick, are you good with me? You look tired, friend. Are you good?
Yeah, I'm good.
All right. So we got a to the what? a to the 1/4. Okay. Now when we're looking at this, you kind of have to decide what you're going to do. This is really kind of up to you, but when I'm looking at this, I want my life to be as easy as possible. I don't know about you guys. When I see this a to the negative 9/4, and I realize there's a positive 1/4 here, guess what I'm probably going to do with my negative? Do what? Move it to the bottom. Yep. 2a to the 4/3. I'm going to put over here, I'm going to have an a to the 1/4 times a to the 9/4. All right, so I get 2 times a to the 4/3. Friends, can I combine what's in my denominator? Okay, so we're good there so far. So we got here a to the 10/4. Now, when I'm looking at this, I'm like, maybe I should simplify this a little bit. I don't like big numbers. So I got 2a to the 4/3, nothing I can do there, over a to the what? Okay. Now, you've got to figure out what to do next. Are those the same base? Are these the same base?
Oh, yeah.
Don't I have to combine? Don't I have to do something exponentially?
Oh,
Now, here's where, if you don't remember number sense, you can always take the numerators and subtract the denominators and see what you get, right? I look at this and I see that 5/2 is bigger than 4 1/3, okay? Because that's 2 1/2 and that's 1 1/3. So isn't 5/2 bigger? Okay, again, if you didn't know that, it's not going to be the end of the world. But if I do that, I'm going to go here. A to the 5/2 minus what? 4/3? What do you have to get? Common denominator. What's going to be our common denominator? 6, right? So what am I multiplying this top one by? 3, right? So that's 15/6. What am I multiplying the last one by? Should be yes too. Wow, I need to get better math on you. Good job, guys. So we got 8/what? All right. Does everyone agree where we got those from? Okay. So then we have our 2 all over a. What's 15 minus 8? Over 6. Notice it is totally okay with the variables to leave fractional exponents. As long as you've got all the stuff that's combined like you need to, you should be in good spot. Now, this means for some of you are you going to have to show work? Yeah, we really need to show work. Okay, let's do the last problem and then I'll give you some other ones to practice. Sound like a plan? Okay, we're going to be going between the two. Oh, this one's pretty. This one should be like,
This one's
how nice is this? All right, you guys try it and then I'll help you. You guys try it and then I will help you. What's this stuff? This one's nice. He's making more sense. It's don't get it goes in the middle. Yeah. Okay. Good. It's the pattern, but you just have to trust, and you have to trust your math, which is scary, right? Guys, because we second guess ourselves all the time. Okay. Let's look at this last one. Can I do the power property on this one? Yeah. So when we're doing this, don't we really get here? 27 to the what power? 1/3. And then we get here x to the 2/3 times 1/3. Correct? Because we're raising the power. So this becomes the cubic root of 27. And this other one becomes x, well, multiply across with fractions. Remember, 2 times 1, which is 2. 3 times 3, which is what? The 9. And then, guys, what's the cubic root of 27? Hopefully you got that one down. 3. We got x to the 2 ninths. How are you guys feeling? Are we feeling a little bit better about these? A little bit? A lot of it? Tomorrow, we have another maze. So excited. Like this.
What was the dog's name?
Tia, but it's not. We have a dog this time. Sorry.
What is this?
Alright, this one's just a maze. Sorry. You saved my dog in the last maze. I'm so happy. Whoever listens to this video is going to be going like, this is the most random conversation this class could be having right now. I would agree. Okay, I'm going to ask you a question. And I just want a yes or no answer. Don't blurt it out right away. Does it equal x to the 1/2 plus 2 to the 1/2? Don't say anything yet. Is the quantity x plus 2 raised to the 1/2 equal to x to the 1/2 plus 2 to the 1/2? All right, give me your answer, yes or no?
No.
The answer is
No.
no. Guys, that's a binomial, not a what? Monomial. You cannot do this, okay? So that's totally illegal. Don't do it. Now, what if I gave you something like this? Is 2 to the x to the 1/2 equal to 2 to the 1/2 x to the 1/2? Yes or no?
Yes.
Exactly. And the only reason I can do that, what was not there this time? Yep, I don't have that plus or minus sign, so it's considered a monomial. Yes, sir. Yes, you may. Are you guys with me on this? Don't slip up on the little things that you already know that are correct. Okay? Make sure that you have those. I'm going to give you an easy one. Let's do the fun one. let's go 10x squared over x cubed raised to, well, let's just go raised to the 1/2. Let's keep it simple. Simplify this one, please.
Oh, that's next to me. Oh, shoot, yeah.
X cubed, yep. All right, are you guys ready? Let's see how you did. Is this, could I do a couple different things here? Could I simplify inside this first if I wanted to? How many of you don't want to have to work with a lot with fractions? If you don't want to work a lot with fractions, could I have simplified those two very quickly? There's nothing wrong with simplifying inside the parentheses first, because that became x to the what? First, because 3 minus 2, right, is x to the first, raised to the 1/2. So then we get 10 to the 1/2 over what? X to the 1/2, which is the square root of 10 over, now, if I don't want to rationalize, do we keep this as x to the 1/2? Right? But what if someone did this? What do you have to do? Don't we have to rationalize the denominator? What would I multiply in order to rationalize the denominator? X and x. So that's the square root of 10x over the square root of what? X squared. So that's the square root of 10x over this. Notice there's no exponents in this answer. This is in simplest radical form, which means you can't have any fractional exponents. All right? So notice, we're going to take it just a little bit different notch tomorrow before the maze. We're going to talk about what if I said you couldn't leave your fractions with your variables. How would we simplify those out? All right, homework is just from the textbook, my friends. Are you guys good with that? Okay.